T cells and B cells. So if that makes sense. So the first worksheet, worksheet number 4, we're going to start out with specific immunity, which is also known as adaptive immunity. So this is the immunity you acquire or you get throughout your lifetime. Kind of like how we were talking about chicken pox or the flu. You only get it once. Well, that's because of your specific immunity, and we'll go through it then. So this first portion is asking you to, circle either of these definitions as innate or adaptive. So last week we went over innate. This week we went over adaptive. So just general defenses that everyone is born with is innate. Your specific immunity is adaptive immunity. It is very precise, it is very specific with certain antigens to fight off certain diseases like the chicken pox or the flu. Those are viruses, but they can also be produced with bacterial illnesses too. And then recognition of foreign molecules. That is also specific adaptive immunity. And hence the word particular. So there are foreign molecules that your body in general detects, but if it's particular, if it's specific, if it's the flu virus, it is particular, it's specific. The first line of defense is innate. What is the first line of defense? Yeah. What is another first line defense? That's the only one. Trick question. Skin is the only one. Everything else is second line of defense. So what's some second line of defense? Okay, what else? Digestive enzymes, yeah. So we went over this last week in the chart. Phagocytosis, fever, inflammation, chemical barriers, that's innate. The third line of defense is adaptive immunity. This is your specific immunity, and this is what this worksheet and this whole study session is going to consist of. And that mainly encompasses your T cells and your B cells. So, like we said, the adaptive or specific defenses utilizes B cells and T cells. This is true. They are able to distinguish molecules as self and non-self. And this is really interesting, because when people have autoimmune diseases, that's when your immune system kind of freaks out and isn't able to detect the differences, But that's with your T and your B cells, which is, it's pretty huge. So that's a consequence if they don't function is autoimmunity, if that makes sense. All pathogens have antigens, but not all antigens are pathogens. This is true. Okay, so let's break down the first sentence. All pathogens have antigens. What's an antigen? Yeah, it's a molecule, but it is a molecule on your red blood cell, right? But what does that molecule do? It doesn't attract antibodies. It's kind of like its face, its identity. If you're type A blood, your antigen on your red blood cell is going to be A because that's the type of blood you have. Does that make sense? So antigens are kind of just like the identity. It's the way that your immune system can monitor, is this a self cell? Yes, if you have type A blood, you're going to have type A antigens, and this red blood cell is going to live, right? If you have a pathogen, and it could be like B or like pathogen or like B, there's no like type B pathogen, but its antigen is saying something else. It's not saying you're type A or type B or anything that you are. It's just saying, that it's a danger because antigen is like its identity. So all pathogens have antigens. All pathogens have, their identity on them. But not all antigens are on pathogens because you have antigens on your red blood cells. Did I just make that better? Makes sense? Okay. And a way you can remember, because we're also going to be talking about antibodies, pathogens have antigens. So the gin part of it, just remember that. Pathogens have antigens. T cells secrete antibodies is false. It is B cells that secrete antibodies. So whenever you hear the word antibody, you're going to think B cell. So for the purpose of the immune system, whenever you hear the word antigen, it's going to be talking about the antigens on a pathogen. We're just going to excuse the red blood cell and everything for now, but just know that all pathogens have antigens, but not all antigens are on pathogens. So direct cell-to-cell contact is known as cellular mediated immunity. So cellular mediated immunity, cell-to-cell contact. This immunity is when your actual T cell goes and kills a pathogen. It's direct, cell-to-cell, cell-mediated. Humoral immunity response does not complete cell-to-cell contact. It utilizes antibodies to travel to the infection site. And that is humoral immunity. So humoral, or humoral, or however Janet says it, what does that mean?
It uses your blood, right?
Yeah. Yeah, it utilizes antibodies. And these antibodies are the things that kill the pathogen. While with cell-mediated, it's the actual T cell that is killing. So see how that kind of kills it, different methods? That's kind of the thing. Humoral, like he said, with, it travels through the blood. That's how antibodies travel, is through your blood. So there's that. That's like the main, key points to this. What are 4 properties of adaptive specific defense? It's antigen specific. Your B cells produce specific specific antibodies to kill the specific antigens on those pathogens. Systematic, okay? Your specific immunity is not only focused on a certain portion. Like if you cut your finger, your innate defenses will kind of inflame, that is local. But systematic, your antibodies, because they travel through your blood, is all over your system. Memory, you have memory B cells, memory T cells that we're going to go through. And this just makes it so they remember what the danger is, because your immunity learns. It gets smarter. And that's why it's specific, because whenever that same molecule infects your body, you have a faster response. Does that make sense? So that's what your memory cells do. And then there's diversity. There's a large diversity of lymphocytes, T's and B cells, that allows the body to attack many types of pathogens. So we're going to learn about, there's 3 T cells and there's 2 main B cells, but then you have all your different antibodies. There's just so much diversity of the immune system. It's very complex, to say the least. But we're only going to be focusing on just a couple cells, if that makes sense. So there is that. And that is also what this worksheet is over. We're going to go over how the immune system interacts with each other. And you'll see a lot of diversity of things. So the next one is just a general definition. Haptens are antigenic that evoke an immune response independently. This is false. Haptens are small molecules. They're not antigenic by themselves, which means they cannot kill antigens on their own. They need to be activated with a larger molecule in the body so they can actually attack. So if you see the hapten in your reading or in your PowerPoints, just know that they need to be activated, kind of like with some of those hormones in the immune system. in the endocrine system and the digestive enzymes, So that's what haptens do. And that's just a general, like, hey, curveball fact. So we're going to start with cellular mediated immune response. In the circle, this is a T cell. These are some little facts. I specialize in the thymus, make up 70 to 80% of lymphocytes. So the majority of your lymphocytes are going to be T cells. They settle in lymphatic organs, lymph nodes, and thoracic ducts, in the spleen, and also in the spleen's white pulp. Cellular mediated immune response, T cells. So that's the rundown of what your T cells do, and you have 3 categories that we're going to go through. So so a lymphocyte, so by the term lymphocyte, we're talking about your T cells, okay? A lymphocyte can respond to an antigen without being activated. This is false. With cellular mediated immune response, the lymphocyte has to be activated before it can actually respond. And it's activated by antigen-presenting cells, also known as APC. And we'll go through the process much more as we move on. But which one are you guys on? Number 4. I just want to see how much space you have to write. Yeah. So the huge one is antigen-presenting cell. And an antigen-presenting cell is typically a macrophage. Antigen-presenting cells can also be B cells and other types of cells, but for this purpose, if you see antigen-presenting cell, it's a macrophage. Basically, what your macrophage does, what your monocyte does, it eats that. So here's our ghost. Our antigen-presenting cell is like our Pac-Man. It's going to eat that antigen, and it's going to dissolve it. Okay? Fragments of the antigen are then going to be, dispersed throughout it. The entire antigen is going to go away. And these are going to go to the surface of your antigen-presenting cell, right? Because it's presenting that antigen. This macrophage, this cell is presenting that antigen from the threat. So even though this is the pathogenic antigen, it's not going to be infectious because it's your macrophage that has it on its surface. And your macrophage will then go to your T cell, or your T cells will come to your macrophage, and it'll detect this. And this antigen on the surface of your macrophage is what causes a T cell to become activated. There's a process, and there are pictures in another worksheet, but this is the main breakdown. Your antigen-presenting cell kind of rips it apart, puts its antigens on the surface, says, hey, this is the threat, this is what you need to be looking out for. T cell is like, all right, I'm on it. So number 11, when an antigen-presenting cell digests an antigen, that's what happened there, it digested it, it displays antigen's cellular fragments on its own membrane. So these fragments on its own membrane, right here, this is called a histocompatibility complex, also known as MHC. So that's what activates that T cell. So number 12 now, we're going to be circling either T or B cell, but since we're talking about cellular mediated, it's going to be T cells. The T cell encounters the antigen-presenting cell, recognizes the antigen as foreign, so it's going to say, hey, this MHC on the surface is foreign, and then the T cell will become activated. So it's a process, right? In order to have your T cells into action, you need that macrophage. T cells then secrete cytokines to increase cellular response to antigens. So first thing, number 1, you have your antigen-presenting cell. 2, your T cell will make contact. And then number 3, your T cell will secrete cytokines. This is the main breakdown of how cellular mediated immunity starts. So this next portion is which T cell am I? So you have 3 types of T cells, and these are like little definitions. So I help activate B cells and therefore help humoral mediated immunity. So this T cell helps with B cells, right? I secrete cytokines to help stimulate the T helper cells, the cytotoxic T cells, and B cells. So the T cell, the first T cell that ever becomes activated is a helper T cell. Helper T cell is the cell that the AIDS virus actually triggers, or targets and kills, and that's why people who have AIDS or HIV have very low immunity, because if you don't have your helper T cells, you don't have any immunity. Your helper T cell is like the main conductor of how immunity happens. So if your helper T cells are dead, the rest of your immunity is going to be really low because it can't direct. They're like the leaders. Because your helper T cell, this guy is a maniac. I perform cell-mediated immunity. So these are the ones that actually go and kill things. I see all the action and directly attack and kill antigens in the tissues. My buddies that help kill these things are called perforons, which help cut pores into the membranes, and lymphotoxins that secrete toxins. I especially like it to attack cancer. I'm a cytotoxic T cell. So cytotoxic T cells are like maniacs. So have you guys seen, oh God, what was it? The Wonder Woman at all? If you have, there's like a scientist, and she's like Dr. Poison or something. I think of her as a cytotoxic T cell. She's the Dr. Poison, I think. Is that what her name was? Something. She's the one who developed all the gases and poisonous things that killed the soldiers. So cytotoxic T cells are like really insane. The next cell we have is pretty boring. I'm created during initial infection, but I do not respond at this time. So when you have the first infection, your memory T cells don't really react. I can differentiate into cytotoxic T cells when I encounter the same antigen again. So your memory T cells are kind of like in training. They're like, oh, this is the threat, this is how we prepare, and they just kind of hang out in your body. But then when the threat comes back again, then they turn into cytotoxic T cell maniacs and destroy things. And that's really important when you have your primary immune response and your secondary immune response. So our memory T cells are the reason why when we get infected a second time, we're able to react a lot more quicker.
So these are 3 different T cells. It's not like one T cell just turning into a different one.
Yeah, the only one that ever turns into another one is your memory T cell. Your memory T cell is the only one that ever differentiates.
There are more T cells, right? These are just the main 3?
Yeah, these are the main 3. But you have more T cells than B cells in your body. So your helper T and your cytotoxic T are like your main, your head honchos. Memory are kind of like, I don't know, in military school. Different attitudes, all of them, different personalities. So some functions of cytokines. Do you guys remember with chemotaxis, your damaged tissue secretes a chemical, and that's what communicates to your immune system that I need help, right? It's kind of the same thing between your T cells and your B cells and your specific immunity. They secrete cytokines. Cytokines are like the messages. So if I'm talking, that's my message, but they talk with cytokines. So functions of cytokines, functions of the message. These activate resting T cells. And whenever I say T cells, I'm talking about all 3 T cells. It activates all of them. It causes T cells to proliferate or divide. Also, it causes it stimulates the production of leukocytes in the bone marrow, right? Because if we have stimulation of leukocytes, which are white blood cells, we can better fight that infection. Cytokines also cause growth, maturation, and activation of B cells. So if you don't have your T cells, you don't have your B cells, because your T cells are what tell your B cells what to do. Your T cells also activate macrophages. So if you don't have your T cells, you don't secrete cytokines. And if you don't secrete cytokines, your immunity does not happen, especially your helper T cells. So basically, cytokines are messengers that carry out actions to other body cells. So like I'm talking, that's communication between us, my words. That's like if I were an immune cell talking to you guys, my cytokine is like my message, or like if I had a word bubble above my head, I mean, that would be my cytokine. So, any questions on T cells so far? No? Okay. Is this helping? Okay, good. So number 16, lymphotoxins are harmless and perform the same action as cytokines. This is false. I mean, this is true. Yeah, this is false. Lymphotoxins are very harmful. What the heck was I doing when I wrote this? Okay, so lymphotoxins either secrete toxic substances that are deadly to antigen-bearing cells, or they inhibit the growth. So they either attack the Pac-Man ghosts, or those pathogens, or they tell them stop growing. They say, they form like a barrier or something, and they just tell them stop growing. Lymphotoxins are lethal substances that kill antigen-bearing cells. So, this antigen-bearing cell, yeah. The antigen, yeah. But it goes out and it kills everything, and it's like, so these guys are like, they're sacrificed too, because like, well, now you don't have a function. So it gets them too, but as well as the pathogen. So if they sense that antigen, they're gonna kill it. And then they also secrete growth inhibiting factors. And this causes your Pac-Man ghosts, your pathogens, to not grow, which is nice because we don't want them growing. We want them dead. So I don't quite know what I wrote when I wrote this question, but this is the main takeaway. I don't even know how, because that was like a fill in the blank and, oh, okay. Yeah, it was a true false. Okay, so in order to change this, you're gonna take out harmless and you're gonna put harmful. And they do perform the same action as cytokines. Okay, because I thought, I confused myself. Whoops, sorry. Yeah, so they're harmful, and they do attack things, so. The next portion is gonna be matching me. So we're gonna be matching the function of cytokines and the function of lymphotoxins. So as you can see, cytokines do everything. Cytokines, which are the messages that I'm talking to you, in the immune system, those messages are able to stimulate interleukin, tumor necrosis factor, which is something that kills tumors, colony stimulating factor. So your cytokines stimulate your colony of immune defenses, and cytokines also trigger interferon. Your lymphotoxins, though, only trigger interferon production. Interferon. Yeah. So remember the graph we had? This, oh dear Lord, which one was it? Remember we were looking over this? Interferon is part of your complement or your chemical barriers, right? So there it is right there, interferon. And when we went down, interferon it blocked viral replication. So the main thing about it is viral replication and tumor growth. So it interferes with the growth. Is that what you were saying? Yeah. Yeah. So it's good to, and this is a chemical barrier. I know this was last week, so. And the difference between these worksheets and all the other ones is your immune system actually interacts with each other. So these worksheets are going to interact with each other versus with the other step, it's like cardiovascular, step 1, step 2, step 3. This is a little bit more complex. And if you have questions, please email me. I'm open for it, especially immune system. So that was cellular mediated, and now we're going to move on to humoral immune response. And humoral, again, or humoral, has to do with your blood. And that is when your B cells secrete antibodies into your blood, and that goes throughout your entire system. So looking at this, your B cells mature in a fetus's liver, but they mature in the red bone marrow during adulthood. So that's pretty neat. Again, liver, really important. So there's that. They really don't know with B cells where they mature. So they just say bone marrow because that's where all your other, white blood cells go, and B cells don't go to your thymus. Your T cells go to your thymus. So they just say B cells are in your bone marrow. Makes up 20 to 30% of lymphocytes, so very, the least amount. B cells, like the T cells, settle in lymphatic organs, and you can find a lot of them in the lymph nodes, the spleen, bone marrow, and intestinal lining. B cells provide humoral immunity. So those are some quick facts. So B cells depend on cytokines from the T helper cells to become activated. This is true. Again, your T helper cells, super important. If you don't have T helper cells, if you're infected with the AIDS virus or HIV virus, AIDS is the condition, HIV is the virus, and your T cells are, dead, you won't have this B cell humoral immunity, or any immunity for that matter. Your T cells, your T helper cells are your main leaders. B cells also need to bind to specific antigens to become activated. This is true. B cells do not need to come in contact with the infection, but they do need antigens, need the antigen to proliferate. So they need the antigen to be present. And then B cells require two-step activation. So with T cells, cellular mediated immunity, one step. T cell detects the antigen on the antigen presenting cell, T cell becomes activated. B cell is a two-step activation. I think it was here, yeah. Antigen presenting cell, T contact, T cell secretes cytokines. There's that. Any question on B cells and differences between T cells so far? No? Alrighty. So humoral immune response is also known as antibody mediated. So antibody, humoral, blood, B cells, the bone marrow, the B, B cells send so what happens is that your B cell sends your antibodies to the infection site through your blood. So your blood is like a channel that your B cells can secrete antibodies into, and your B cells do not come in direct contact with the infection. So to kill the infection, your B cells don't really come together at the beginning. So, at the end of it, when it has to kill it. However, in order to become activated, your B cells do make contact, but to kill them, they use antibodies, and that's the main takeaway. Did that just sound contradictory? It's hard to explain because you can't see it. That's really the hard part with the immune system. And it's hard to understand.
It's different stages, like you send their antibodies in and then
Yeah.
come in?
Well, the thing is your B cell, so your T cell needs this to be, your antigen presenting cell. Your B cell, though, on its own can kind of detect the Pac-Man ghost and be like, ooh, I'm not touching that. And it'll kind of like travel to another portion of your blood, of your body, and start secreting antibodies like kill, 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 kill. So your B cell does kind of touch the infection initially, like at the very beginning, but to kill it is different. It's humoral. It kills it by sending antibodies through the blood. And that's where a lot of confusion happens, because your T cells work a different way. We'll go much more in depth with worksheet number 8, though. That one will hopefully clear things up a little bit more. So yeah, your B cells use antibodies to kill the infection. So now we have 2 types of B cells. You have your memory B cell and your plasma B cells. So your memory B cells are like your B cells in training, okay? They're the ones still in military school. These provide future immunity. But in the meantime, they kind of remain dormant. They don't really attack anything. They're still in training. But then when the infection happens again, these memory B cells, they get bigger, and then they clone. They clone into like memory B cells or plasma B cells until, when they see that exposure again, when they see that there's another pathogen in your body. Does that make sense? So basically your memory T cells and your memory B cells both turn into other cells. And they are both in training, they're both dormant. Except for your B cells either turn to memory B cells or they turn to plasma B. And your plasma, right, blood plasma, right? We have blood plasma, which is the liquid portion, the humoral portion of our bodies. Your plasma B cells are the ones that kind of like touch an antigen. They're like, oh, I'm not touching you. And then they start secreting antibodies. That's your plasma. They start creating antibodies into your blood plasma. So I produce antibodies. Antibodies are also known as immunoglobulins. Antibodies have a unique sequence and conformation of amino acids. So by that it's saying, on the surface of any antibody, you have proteins, and those are called amino acids. So if you get a question about, what is on the surface of a antibody, you're going to say amino acid or protein or something, if that makes sense. It's not really that important, but if you see it, it's there. And these different, well, it's really important, but not to know for an exam maybe, but it's really important because if you don't have these different proteins, these different amino acids on the surface of your cell, that's what makes them so specific, is the things on the surface. Just like our faces are our identity, for our cells, that is their antigens. That's the stuff on the surface of their cells, those proteins, those amino acids. So I don't know if I mixed that up a little more, but hopefully that goes through. So we're going to go down, and now that we're talking about B cells or humoral mediated immunity, these are just some of your antibodies, okay? So we're going to be talking about the different types of antibodies, and then we're going to see how the different antibodies attack a pathogen, which is with the Pac-Man ghost. So this kind of flows into this next worksheet. So you have different antibodies. They all have different locations, different functions, their main special ability. So these are like what I had you guys write out are like the keywords. Like this is what you need to know. And these are just a couple examples. So your IgG makes up 80% of the antibodies in your blood. So this is a good whopping portion. You can find a lot of these IgG antibodies in your blood plasma and your tissue fluid. IgG, attacks bacteria, viruses, and toxins. And the interesting thing about IgG is that they can cross into the placenta and provide passive immunity. So what is passive immunity? Yeah. Yeah. So like the mother's blood passes on to the baby. because the mom's blood is what circulates throughout the baby's blood when she's pregnant. So with passive immunity, they have those immune cells. They have those IgG cells to provide immunity against those simple things. It's a defense mechanism to protect that baby. However, what makes it passive is that when the mother, when the mother is pregnant, the baby's immune system, it's kind of piggybacking off the mom's. It's not actually producing any memory B cells, T cells, or anything. The baby is very passive. And then over time, those IgG antibodies will be destroyed in the baby, and that's when the baby starts actually making its own immune cells, is once the mother's protection is gone. So placenta and passive immunity, IgG, important. Some examples are anti-RH antibodies, so Rh negative. So this can also be beneficial to any baby, for any disease, because there's a variety, and I didn't list them. But your IgG could also be very harmful to an infant, especially if it's the second infant of a mother who is Rh negative. So that's your IgG. IgA, the location are in glandular secretions, so that's a good thing to know that it's in your glands, it's in your mucus, your saliva, your milk, and your tears. Well, not male's milk, but female's milk. So IgG, when the mother is pregnant in the womb, that's what provides protection. When the baby is birthed and the mother breastfeeds, she provides those IgA antibodies, which continue to protect the baby. So that's a good thing too to know, is it's in your glands, IgA. These, because they're on your mucus lining, these attack antigens before they gain access to your internal tissues. So because they're on the surface, they're kind of like a barrier, IgA is. IgA also provides passive immunity to the babies through milk. And there's no real example of an IgA, so they're just kind of there against diseases. So the next one, we're going to go here. We're going to IgM and IgM. So IgM is only 6%. You can find this primarily in your blood plasma. IgM detects bacteria and food antigens. So food antigen would be like something on your food, like food poisoning or some bacteria or something on it. And then when that bacteria or that antigen is in your blood, IgM agglutinates, and it kind of glues to the surface to prevent the antigen from dividing or from infecting or damaging any other further tissues. So IgM agglutination is a huge part. Something really neat about IgM. So I think about IgM as your military, your main force, your main antibody. This is the first antibody secreted when the antigen is detected. But then your IgM skyrockets when you first get an infection. But then very slowly IgG, also known, what I like to think about is the government, comes second, kind of levels up there, and then IgM kind of goes away. So IgM kind of goes and clears everything out and tries to take care of things, but then IG government kind of steps in and is like, okay, we can handle this now, away with you military. If that makes, that's not really how it goes, I don't know, but it's just a way to remember it. I don't know anything about military government stuff, so. Pretty. Or do I? So, some IgM antibodies are with your red blood cell, right? If you're type A blood, you're going to have type B antibodies. That fits under the classification of IgM. IgM antibodies are those type B. If you have type A blood, you have B in your immune system. Type B blood, you have A in your immune system. If you're type O, well, you have both. Or if you type AB, you have none. That's your IgM. Your IgM is your antibody A and your antibody B in the blood. So this is the not on the surface of the red blood cell, but the immune system that will attack red blood cells that are different from yours. Make sense? Okay. That's what antibody A, antibody B. So whenever you see the word antibody, talking about immune system. Always, always, always immune system. So IgE, very insignificant but important. IgE is the antigen that is glandular and also exocrine secretions. So an exocrine secretion would be like your sweat glands or other glands that secrete on surfaces of things. So your IgE is really important for allergies and inflammation. These are the things. So antibodies, again, are your kind of like cytokines, are your communication. They're chemical messengers. So whenever there's someone has a peanut allergy, okay, that peanut allergy is detected by your immune system. Your immune system secretes IgE. IgE will then travel and attach itself to a basophil and be like, hey, basophil, there's a peanut allergy, we're detecting peanuts, what do we do? And then that's when your basophils, or also your mast cells, release histamine and heparin. So there's no real thing that you really need to know about it. It's just there. But yeah, allergies. Yeah. Yeah, there you go. IgE, allergy. Just don't mix it up with any of the other ones too, because they can all sound the same.
Well, definitely remember the military.
Yeah. Yeah, that's the one. Yeah, but IgE, allergies. That's a good one. The next one is IgD. Very little bit in the body, but very important. These are on the surface of most B cells, so especially in infants. So again, infants. These act as an antigen receptor. So IgD antibodies are an antigen receptor. I wish they didn't make these things sound the same. I wish they were different words. IgD is really important for B cell activation. So that's the main takeaway with IgD. It activated, IgD activated B cells. I don't know. There's no IgB, so I guess that's D and B. Like when you're a kid, you got them backwards all the time. I guess that's, I don't know. I'm trying to think of ways to remember these.
Just do the odd one out with that one and try to remember the other ones too.
Yeah, just remember the other ones, and this one is just, it even, unfortunately, it has the smallest box too, so it's like, okay. So now we're going to move on to the antibodies in action. So we just went over specific immunity, right? Just as a brief rundown. As a whole, we went over immunity, right? And we just hit on specific immunity. Specific immunity consists of what?
T cells.
T cells.
T cells.
Okay. T cells is also known as what? Cell mediated.
Oh, yes.
Yeah, but T cells, yeah. So cellular mediated, and then you have B cells, which are also known as like your humoral immunity. So for now, we're kind of done with T cell. With B cells, we then talked about this chart, which was with antibodies. I should make a graph of this, a big page of this. I'll send it out. That'll be a nice worksheet, actually. And then and then this next worksheet we're going to go over soon. Worksheet number 5. This is your antibodies in action. So this is kind of how it all ties together. And I'll create maybe a worksheet that'll show you how it all connects. Yeah, flow chart, yeah. Oh my God, I don't know why I didn't think about that before. Very nice. Yeah. Why didn't I? So, all right. So that will be the next one.